Hello, my name's Alex Thornton and I'm an Associate Professor of Cognitive Evolution here at the University of Exeter. What that means is that I'm interested in understanding how animals' minds work and why they work that way. How have the cognitive processes of animals, including humans, evolved? By cognition, we mean the set of mental processes like learning and memory through which animals acquire information from the environment, process and store that information, and use it to make decisions. So how and why does the range of cognitive processes used, what we might broadly think of as intelligence, differ between different species? For thousands of years since the time of the ancient Greeks, the history of Western philosophy has been dominated by the idea that life is organized as a scala natura, a great chain of being leading from rocks and minerals to plants, lowly animals, and then up to us human beings, with the divine beyond. As a hangover from this idea, people often assume that animals' cognitive abilities are also scaled in this way, with animals that are most similar to us, like chimpanzees and gorillas, sitting near the top of the ladder, and other lowlier, less evolved animals being basically simple, dumb automata. But this is based on a fundamental misunderstanding of how evolution works. Evolution is not a ladder leading neatly up to human beings, but instead, as Darwin taught us, it's actually more like a branching tree. We sit on one tip of one tiny twig of one tiny branch of this great tree, and we're no more or less evolved than any of the other creatures on any other tip of a branch of the tree. So, how does this help us to understand animal intelligence? Well, first, it highlights that we're all related. Not just you and me and all other humans, but us and chimps and octopus and beetles and worms as well. So there will be some commonalities in the way that we all process information. But perhaps more importantly, it means that rather than just assuming that intelligence is determined by how human-like an animal is, we can examine how its cognitive abilities have evolved to solve the problems that it actually faces in its natural environment. So think, for example, of an Arctic fox, perfectly camouflaged against the polar snows. This is a beautiful example of a biological adaptation, a trait that's favoured by natural selection because individuals that had that trait were more likely to survive and reproduce and pass on their genes. Well, we can also begin to think of cognitive adaptations, aspects of animals' minds that have evolved to process information to cope with the challenges of their daily lives. Broadly speaking, those challenges might be social or ecological. For example, one critical ecological challenge for every animal is finding enough food to eat. For animals that live in temperate climates, this can be especially difficult during the cold winter months. Some animals solve this problem by hiding food in the autumn to tide them over during the winter. You may well have seen a coal tit or a jay caching seeds or acorns in your back garden. But for animals like these that hide food in lots of different locations, there's a major cognitive problem. They have to remember where they put their food. After all, there's not much point hiding food if you can't find it later. And to solve this problem, these food-storing birds have evolved some extraordinary cognitive adaptations. If we compare food-storing birds to related birds that don't store food for the winter, we'll see that the food storers tend to have a much larger hippocampus. That's the area of the brain associated with learning and remembering spatial information. This gives them remarkable memory. For example, one bird, the Clark's nutcracker, which is a bird of the crow family that lives in the forests of North America, can hide up to 30,000 pine seeds. And then it finds more than 90% of them several months later, even when the whole forest is blanketed with snow. If, like me, you lose your keys on a daily basis, this ability to remember where you put things is absolutely breathtaking and really rather humbling. Food storing also gives us a nice example of how ecological challenges can drive cognitive evolution. But actually, for many animals, the most challenging problems are often social. If you reflect on your own life, this might well ring true. For many of us, the most mentally taxing challenges that we face involve dealing with other people, managing relationships, figuring out how best to cooperate with others, and avoiding being duped. In fact, the most influential explanation for the evolution of humans' big brains and our intelligence is that they're necessary to help us to deal with the challenges of social life. And there's also evidence that this applies to other animals too. Among birds and mammals, for example, the species that live in large groups or that form long-term social relationships also tend to have particularly big brains. There's even evidence that social life can produce cognitive adaptations in insects. For example, one study examined whether paper wasps from two different species can recognize the faces of other individuals. Next time you're having a picnic when we've all emerged from lockdown and are blinking in the sunshine, have a good look at a wasp's face, and you'll see that it has these really striking black and yellow markings. And if you look carefully, you might notice that these markings differ among different individuals in the same way that your face is different from mine. But can wasps really recognize each other's faces? Well, in this study, in the species, when they looked at the species that forms social groups with a dominance hierarchy, the answer was clearly yes. These wasps were really good at learning to discriminate between the faces of different individuals of their own species. But the other, more solitary species, on the other hand, didn't show this ability to recognize faces. So what this implies is that the ability for facial recognition evolves where it can provide benefits. And this is generally the case. We can't rank animals' intelligence on the basis of how similar to us they are. Instead, we need to recognize that animals have evolved to be as smart as they need to be to solve the particular challenges that they face in their environments. And in some cases, like our food storing birds that, unlike me, remember exactly where they hid things, they can be smarter than we are. So this just gives you a little taster of the sorts of things that you might learn about if you choose to come and study with us here at the University of Exeter, where we have one of the biggest groups of leading researchers working on behaviour and cognition in animals and humans anywhere in the world. So I hope you'll join us. Thank you.